Hey YouTubers, welcome back. This is Eli the OBD Tech. I'm here working on this 2010 Chevy Impala LT. It's an LT with the 3.5 liter engine, non-flex. So this vehicle pretty much was brought in due to the fact that it has a check engine light. It's regarding some EVAP codes. Let me show you guys real quick. It has a P0442 EVAP system small leak detected, and also a P0455 EVAP system large leak detected, and a P0253, that's an engine oil pressure sensor circuit high voltage. Perhaps there's an open in the system, perhaps a faulty pressure sensor. That's going to be probably perhaps another video. We'll see if it happens or not. But for this one's going to be based on the two EVAP codes, a small leak and a large leak. I've already pretty much pre-diagnosed the vehicle. I've already concluded what's the problem. The vent solenoid is working properly. The fuel cap is working properly. I checked it. It passed the test. I actually have one of those fuel testers. And the culprit problem, in which the customer stated that he actually replaced it about 3 months ago. He replaced it with an aftermarket. I believe it was from AutoZone. It's a Duralast brand. So after 3 months, it has gone bad. It's right there. As you can see, sorry for the glare. It's about 3 months old and it has already gone bad. I've already bought the original GM genuine part here. Part number for those that want it. It's either 214-1473 or GM's number is 1259-2015. Here's the original. So I have concluded that the problem is the purge valve that's causing these two codes. And plus, I think the owner needs to do the smog on this car too. So he wants the check engine light gone. So let me show you guys real quick what I did to pretty much conclude that the problem was a purge valve. It's not always a purge valve, but for this vehicle, it is a purge valve, especially because it's an aftermarket part. Go figure. All right, so let me go ahead and set you guys up. I'm gonna do the special test, the purge seal, and show you guys how this faulty one is behaving or not doing what it's supposed to do when you command it to do something. This vehicle has actually an air pump. Sorry for the glare, guys. I'm gonna go ahead and select EVAP system, purge, EVAP purge seal. Hit continue. I'm going to select some of the pits. The most famous one, which is 4 of them. It's the fuel tank pressure sensor, inches of water, EVAP purge solenoid command, the fuel tank pressure sensor, voltage, and the EVAP vent solenoid command. Alright. This is pretty much the norm with the key on engine off. Your fuel tank pressure sensor voltage should be around, hovering anywhere from 1.4, 1.6. It's around 1.5, which is good. Your fuel tank pressure sensor, inches of water, should be around close to 0. So far, it's within the norm. But where it's not within the norm is when the vehicle is on and you're commanding the system to purge and then seal. So let me go ahead and turn the vehicle on and perform this test for you guys real quick. Alright guys, so with the vehicle on, current computer is commanding 0%. Just wait for it until the computer goes ahead and commands some type of purge duty cycle before I do the purge and seal EVAP test. Let me pause, and once it starts purging, I'll come back. Alright guys, so the computer has commanded the EVAP purge cylinder to turn on around 14% of duty cycle. You can see there's no movement to the fuel tank pressure sensor, inches of water, or the voltage on the fuel tank pressure sensor. Now let me go ahead and do the purge and seal. %, nothing's happening. 20%, nothing's happening. 30, 40. There's a little bit of movement on the fuel tank pressure sensor, inches of water now, but still 1.5 volts. 50. Still, that's not enough data change on, hit on the fuel tank pressure sensor, inches of water. So at 60, seal. Around 30 to 40% the vehicle should be running rough due to the fact that it's sucking in fuel vapors into the intake manifold, and fuel trims are going negative. In this case, nothing happened. As you can see, it's sealed, not venting. I'm gonna vent now. Alright, so now another quick test is to go ahead and use the handheld vacuum here. Pump, remove the canister hose that goes to the charcoal canister. Apply some vacuum, and it should hold vacuum as you pump. Let me apply that test real quick and show you guys that for this faulty aftermarket purge solenoid is not doing what it's supposed to do. Alright guys, so with the vehicle off, I've already connected the handheld vacuum pump. I've removed the hose from the canister that connects to the purge solenoid valve. I'm going to try to apply some vacuum into it. We'll see what happens. As you can see, it's wanting to go up, but it cannot create any vacuum. So right there, that's the first indication that this is a faulty purge valve that can no longer hold vacuum. Alright, so now let me go ahead and show you guys the difference with the good working canister purge valve. Let me set up and I'll show you guys real quick. Alright guys, so with the original GM product here, I've already connected the handheld vacuum pump to it. I'm going to go ahead and apply some vacuum, and let's see the difference now. Sorry for the glare from the sun. Here we go. About 10 inches, 11. It's holding vacuum. It wants to hold vacuum. There you go. It's steady now. So that right there tells you or shows you the difference between a good one and a faulty purge valve. Now I'm going to show you guys with the new one installed, show you the data on the scan tool by doing the purge and seal, and show you guys how the engine will behave once you command the system to purge. Fuel trims are going to go negative because it's sucking fuel vapors into the intake manifold, so it's going to run a bit rough. Alright, so let me set up and show you guys real quick. Alright guys, so with the original GM purge valve installed, I'm going to perform the purge seal. Currently the computer is not commanding the purge seal. It's at 0% duty cycle. Just wait for it until it starts, until the PCM commands it to turn on, and we'll see some type of fluctuations here on your inches of water and your voltage. Not a lot, but once I perform the purge and seal, you'll see the difference, and we'll see, hopefully the camera could pick up the how the engine will run a bit rough once we hit 30 to 40% duty cycle on the purge. There you go, 14%. I do hear the purge valve kind of with the minimal duty cycle clicking inside the case or housing. There you go. Now you see there's some fluctuations at 14%. Voltage is fluctuating for anywhere from 1.3 to 1.8. That's a good indication that our problem was a purge valve. So now let's perform the increase of purge, and I'll seal it. So there you go. I did hear the vent valve close. Now shows not venting. 10%, 20%. Let's look at our pits. First and third pit. Oh, they're gonna start. There you go. The engine did run a bit rough at 30%, now 40%. There you go. Run a bit rough. I'm gonna seal. There you go. 2.7, 2.6 on the voltage. Negative 5.6, and slowly it's gonna start decreasing back to close to 0 inches of water. The voltage should go back to 1.5 slowly. So there you go, guys. So that's the difference between a good working purge solenoid or a good EVAP system where all the components are working properly. I'm gonna go back to venting, bring everything back to normal. We should go back close to 1.5 and back to almost close to 0. The computer right now is commanding 50%, so it's gonna be all the way to the normal range, but there you go. So hopefully you guys enjoyed learned something here, enjoyed the video. This is Eli the OBD Tech. Subscribe to like.